Hello students, in this video we'll discuss the law of total variation. If we're given two jointly distributed random variables, x and y, then the variance of x can be computed by finding the variance of the conditional expected value of x given y plus the expected value of the variance of x given y. And this result over here, which breaks the variance into two components, is called the law of total variation. And so let's see how we go about proving this. So let's recall. Let's look at these individually. So the expected value, so what would this first variance be over here? So the variance, let's look at this first term over here. So the variance of the expected value of x given y is equal to the expected value of the square of this random variable. So I'm going to square the expected value of x given y. That's squared. And then I'll do the square of the expected value of the expected value. And now if we look at this first term inside the parentheses over here, this is the expected value of the conditional expected value of x given y. So this is just the expected value of x, quantity squared, by the law of total expected value. So we can simplify this as the expected value of the expected value of x given y squared minus the expected value of x quantity squared. So we'll keep that on one term. Let's look at the second term over here. So the second term in this expression, the expected value of the variance of x given y. Well, now we'll compute what the variance of x given y is. So this is the expected value of, to compute this variance over here, the variance will be the expected value of x squared given y. And then I have to subtract off the expected value of x given y, the expected value of this, quantity squared. And so what we have is we have the expected value of x given y minus its expected value squared. And so now what we can note is we can note that this is the expected value of x squared given y. And then over here what we'll have is we're going to have the expected value of x squared. Because we have the expected value of x given y. So this will be the expected value of x the square of this. So we have the square of this. The square goes on the outside, not the inside. So the square of this. X given y, the expected value of this squared. And so now what we have is we see that when we add these terms together, so the variance of the expected value of x given y plus the expected value of the variance of x given y will be 4 terms total. It will be this term over here and this term over here. Well, those terms are exactly the same, so those terms will cancel. So this term over here will cancel with this term over here. And we'll get the expected value of x squared given y. And then minus the expected value of x quantity squared. And now, by the law of total expected value, we see that this term over here is exactly equal to the expected value of x squared given y. That conditional expected value is exactly equal to the expected value of x squared. And so all total, we have that the variance of the expected value of x given y plus the expected value of the variance of x given y is equal to the expected value of x squared minus the expected value of x quantity squared, and that is exactly equal to the variance of x, and that proves the law of total variation. So to summarize, when we compute the variance of the expected value, that is the expected value of the square of that random variable minus the square of its expected value. And when we find the expected value of the variance, that's the expected value of the whole quantity of the expected value of x squared given y, and then minus the expected value of that random variable, x given y, squared. And so these two terms over here will cancel out, and we can conclude that we have the expected value of x squared minus the expected value of x quantity squared is equal to the sum of those two expressions, and that proves the law of total variance. Thank you very much.